we're going to verify the test for divergence. That is, suppose we have a series from 1 to infinity an. If the limit as n goes to infinity of the sequence that gives us a series is not 0, then the series diverges. Now this is the statement of the test for divergence that's most useful, but it also is equivalent to the following statement. It's called contrapositive. If we negate the conclusion, which means that instead of the series diverging, it converges. So if we assume that the series from 1 to infinity an converges, that implies the negation of the assumption in the previous statement. The assumption was the limit is not 0, so here limit will be 0. These two statements are equivalent. We've been using the first one in practice because it's easier to use to identify series that diverge, but we'll verify the second statement, which also means that the first one is true. So we're going to suppose that the series from 1 to infinity an converges. Now what does it mean for a series to converge? So if we form a sequence capital S sub capital N of the nth partial sums, so Sn here is the sum of the first capital N terms of our series. We can write it using sigma notation as little n goes from 1 to big N of an. This sequence will also converge to the same value that the series converges to. So this is summation from 1 to infinity an is equivalent to the limit as capital N goes to infinity of Sn, and let's say they go to finite number a. But now let's form the following sequence of partial sum. It's called the sequence of n minus first partial sum. So Sn minus 1 will be our sequence, and this one we can start with also n equals, say, 2 to infinity, and Sn minus 1 is the sum of the first n minus 1 term. So this is a1 plus a2 plus all the way up to an minus 1. And we can write it using sigma notation as little n1 to capital N minus 1 an. Now clearly this sequence will also go to a. This sequence will converge to a, and so we can write the limit as capital N goes to infinity Sn minus 1. This is also equal to a. And now look what we can do. We have 0 equals a minus a. The first a is the limit as capital N goes to infinity of Sn. The second a is the limit as capital N goes to infinity of Sn minus 1. And this is the same as limit capital N goes to infinity Sn minus Sn minus 1, which we can write as, again, limit n goes to infinity. What is Sn? It is a1 plus a2 plus a3 plus an minus 1 plus an, and it's minus Sn minus 1, which is a1 plus a2 plus a3 plus an minus 1. Well, you can see that a1's cancel, a2, a3, an minus 1, and that just leaves the following limit. That leaves the limit as n goes to infinity of an, which is equal to 0, as we saw above. And that proves, verifies the test for divergence. For more videos, visit www.mathprepvideos.com.